Thank you, Galaxy
That
Quest, for
is
letting.
that is a beautiful thing.
Uh, I mean, there isn't much more to say, but like, you haven't probably watched that in about a year, right, Jeff? Does it hold up for you?
But most of the year, I mean, I love it. It's always fun. Um, it's just, yeah, it's just silly. It's good. It's entertaining. Yeah, it makes you feel hilarious.
I I absolutely love it, and it's not just because I grew up watching Star Trek all those times. It it literally is a movie in a time when movies take themselves way too seriously. That from the outset says it's not going to, but still uh like like involves your heart and your emotions. Like if you don't feel anything for the Thermians, this movie doesn't work. And the only reason you feel something for the Thermians is because of the acting of all of those actors. Like I know like there was good writing in behind it, but like a movie that you get a sense of like this is all a big joke, but at the same time you're like helpless not to have these great emotional experiences from it. It's fantastic. And then when you overlay like the Star Trek fandom and like just the fandom in general, it's just quintessential. It just makes me feel good. I love seeing this movie over and over again. All right, we are transitioning now to talk about the science of this movie, which is ridiculous because this movie would think of us doing a presentation about the science of this movie as a just an absolute statement about fandoms. But we're gonna do it
Exactly.
anyways.
Yep. Before we get going, we got to comment on just that mullet in this shot, in this promo shot on Tim Allen is just something special.
Mullets defy science, but I am here for a big prediction. I think mullets are going to be the official haircut of the quarantine. So give it another few weeks. Um, we're all going to be sporting mullets in some way, shape, or form, and it's going to be okay. We're going to get through that
I
together.
mean, that's a fair prediction. I'm still going with the faux hawk. That's what I'm going to keep pulling. But
That's
yeah, the mullet is potentially not too far behind.
all right. So before we get to the science, so Birth Movies Death, which is a famous film review and commentary site, um, had a poll out in 2013, I believe, that looked at the best Star Trek movies of all time. Not 2013. It was 20. It was only a couple years
13.
ago. I thought it was only a couple
23rd.
years ago.
Maybe Birth Movie's Death. But my notes said that this was a Star Trek con in 2013.
Oh, and they voted on it. Okay, but
Yeah.
anyways, they ranked the greatest Star Trek movies of all time, and here's where Galaxy Quest came in seventh. And we're here. The only reason we're putting this on the screen is that it is four spots too low on this list. This is ridiculous. Like if you had your Star Trek rankings, where is Galaxy Quest?
I mean, it's solidly in number 3 or 4 spot, I would
I
say.
I think it's four. I think it's three. I think it's better than Undiscovered Country. I think Rathacon one, First Contact two, and then Galaxy Quest for me.
I mean, this was whatchamacallit, Beyond came out after this, and I actually really
Yeah.
like Beyond. So I would put that fairly high. I don't know if I'd put it above
Where
Galaxy
would you
Quest,
put
but
Beyond?
I might put it at 5. I'm not a
What?
huge fan of Undiscovered Country. I really like Beyond. I've done the science of that before, and there's some actually really good and really iffy science, but I find that a fun movie to watch. I
Well,
really like
like
that one.
I cannot, in good conscience, put that movie in the top 10, given that one of the plot devices is that they used a Beastie Boys song to blow up a series of ships in that movie.
That
That
is one of my favorite parts of that film.
what? All right. Well, we'll come back to that another time.
I mean,
Let,
yeah, as multiple people are pointing out, Into Darkness at the bottom is fully
oh,
accurate,
no
and
doubt which one is in last place. Into Darkness by far and away. Oh, it's not a movie about Khan. Hey, that's enough of that.
blah. Moving on. All right, so let's talk about the historical documents, the historical records that the Thermians get. And so, this is a real thing. This is shown in a few different movies and referred to in the movie Contact and other places, what's known as the Earth's radio bubble. So radio and TV waves are just a kind of light wave. And so that has been going out, being, spread out into the universe from Earth for, 70, 80 some odd years now, 90 some odd years now. The speed of light is 670 million miles per hour. So you can calculate, how far the signals from various shows or world events have gotten in our galaxy. And so this little chart here is a few years old. This is from 2014. So you kind of got to shift everything a little bit further even. But you see some of the bright stars in our galactic neighborhood marked on here, along with some of the shows that they've seen. And so we know the Galaxy Quest show was on the air in 1982, and the movie we watched came out in 1999 when it took place. So they basically got TV from 17 years before the movie occurs all the way back to the beginning. So they needed that time to presumably build the Protector. They mentioned seeing Gilligan's Island, which is, on here. Interesting, they also would have gotten Star Trek, the original series by then. They would have also gotten the animated series by then. So they would have had some Star Trek if this is in our universe, but perhaps not.
If they had seen 80s TV, though, why wouldn't they model this after Knight Rider, is my question. Because I think that's the one I would have gone with. Like, better theme song, and then you would get a hero that just I think makes more sense, and then we would get a movie with David Hasselhoff in it coming back. So maybe that's the sequel.
Maybe, we'll see what Paul Scheer does.
Okay, so let's give him the pass on the radio TV waves. How about the Nebula burst?
All right, so they kind of a couple of throwaway lines about the Great Nebula burst doing something that destroys their home planet. So nebulae, as I was ranting about earlier, are just sort of agglomerations of gas or dust in space, not much denser than, certainly less dense than the best vacuums we have on Earth, and not much, they're denser than empty space, but not too crazy. And they don't really burst. Nebula is sort of just this generic term of gas and dust around either an old star or a young star, things like that. So on the left of these images, we have a picture of OMC1, which is a cloud in Orion, 1,500 light years away. And this is a new stellar nursery. So stars started forming here about 100,000 years ago. And so there's sort of a couple of really massive stars that have started doing fusion and giving off energy and light a couple of thousand years ago or so. And so that is potentially blowing out this material and kind of pushing gas away and giving us that kind of starbursty looking image on the left. But, it's not really a burst. It's not really going to destroy stuff. And it's a very young system. Planets haven't formed yet. Thermians haven't had time to evolve on those planets that don't exist. So, all right. On the right, we have something called a planetary nebula. It has nothing to do with a planet, except it sort of looked like a planet in old telescopes. It's a really crappy name. Astronomers are bad at naming stuff, and they just stick with them. So sorry, that's what we got. So that is an image of something called the Butterfly Nebula, a few thousand light years away. And it is gas and material expanding away from a dying star. It's expanding at 600,000 miles per hour. But that's actually kind of slow on the scale of any kind of explosion or anything like that. And it's spread over a really wide swath. Those butterfly wings are about 2 light years across. So, and again, it does this sort of gently over tens or hundreds of thousands of years. And so there's not really any kind of burst that's going to disrupt a planet. You might have a star eventually swallow its planet. It puffs up at the end of its life. But I don't know. There was some wonky technobabble here that with a couple of changed words, they could have gotten some astronomy right. So I really wish they would have asked me in 1999 to help them write this script.
You mean like 10 years before you got your like PhD, you wish they asked you like to be an astronomy consultant on this film?
I mean, I knew some basic astronomy in high school. I could have consulted.
Oh, what's going on?
All right.
Oh,
the next,
sorry.
It's all good.
Here we go.
So the next astronomy thing I want to get into is the black hole. And so we see the black hole a couple of times in the movie, ships and people going through the black hole. the bottom left is also supposed to be a movie, doing a similar thing here. But yeah, so we see in the movie multiple times the ship and people going through a black hole. And this visualization, I don't know if they accidentally got this right or purposely, but it's not bad. On the left is an actual computer simulation of a black hole, maybe a few times the mass of the sun, with a star nearby that it's actually siphoning material from. And it forms this disk around the black hole, and you get this sort of little stream connecting the disk around the black hole to the star itself. And so that's really kind of what we see in the movie. It's pretty impressive. When I watched this more recently over the past, decade or so, as I was doing astronomy research, this is sort of what these simulations and artist renderings actually look like. So kudos to them for getting that right. As far as traveling through a black hole, there are math equations and theories that say you can go into a black hole and pop out somewhere else in the universe. And that's sort of what they show in here in the movie. But we don't actually know how to physically do that. The forces would basically crush any kind of material that we throw in there. Any kind of connection to another part of the universe would close as soon as you put matter into it. So there's some logistical problems, but maybe the Thermians figured it out. So that's pretty cool.
Yeah, and Furious mentions there's a great Scott Manley video that he did not too long ago about the relativistic effects of going into a black hole. So check that out. I'll paste a link later.
Yeah, there's entire talks and presentations that we could do all about black holes and relativistic effects and wormholes and neat stuff like that.
All right, let's talk about magnetic mines.
Let's.
All right, you should be able to hear. Oh wait, I muted it. Hang on. Okay, we're gonna watch the scene again.
Oh God!
I do like his acting. Oh God.
Could you possibly try not to hit every single one? Sorry, man, they're drifting towards us. I think they're magnetic.
I think they're magnetic. Oh, Amy Auslander has a good question about when you say pop out somewhere else. Where do you mean when you say pop out?
Yeah, so there's theories and math equations that work, but it's unclear how that might physically work. Where you have a black hole that actually may connect to another point in space, potentially significantly farther away. And so the stuff that would go into the black hole could, in theory, come out the other end in some sense, and we would refer to that as a white hole. And then sort of the connection of the black hole to the white hole is what people refer to as a wormhole, which gets thrown around in sci-fi all the time. And so sort of the equations of relativity work out such that a black hole and a white hole could connect, and you could connect very, very distant places in space and be able to travel sort of through this wormhole and instantly get somewhere in a completely different place. Sort of, taking in San Francisco, you take the BART, you go in the Transbay Tube, you go suddenly from Oakland to San Francisco, except you're connecting various places in the universe with these things. Physically, we don't know how it works, but the equations say it's possible.
So
yeah, negative mass, that's all you need.
Two questions. Would it be a random location or would it be a predictable location based off the math that exists?
So it would be a consistent location. So it's not just you roll the dice, you go through a black hole, and you pop up somewhere, and it changes every time. Would we be able to, from one side, from our side of looking at the black hole, be able to tell where that's connecting to on the other side? I don't know. I don't think so. But I'm not sure. That's an interesting question. It is a consistent connection. But as far as trying to map that from our side of the black hole, I don't know that you could do that, because one of the things of black holes is, nothing, not even light, can escape it. No information can come out. So from observing a black hole, my instinct would be you don't know where it's going to be. You have to go through it, pop out, take a look around, open up your GPS, figure out where you are, and then pop back and tell your friends where you ended up, I guess.
The second question is a little more rhetorical. It's white hole? Really? That's the name that astronomers came up with for
the
that phenomenon? White hole?
It's the opposite end of a black hole. That's the idea, I guess. But,
I get it. It's not good. It's not good. I'm gonna say.
I'm telling you, astronomers suck at naming things a lot of the time. I don't know.
Lonnie, thanks for the follow, and good to see you here. Okay, magnetic mines. Let's just agree that the minefield is a strange science, right?
Weird. It's weird stuff, man. It bothers me. Somehow they're all just staying stationary in space, but they're all magnetic enough to follow a ship, but not enough strong enough to pull on each other. And so maybe you can set up something stable internally, but then the end ones, like there's a weird boundary condition mathematically. That's a problem. Maybe they have some kind of motion sensor that turns on the magnet. Like I could kind of buy that. But then at that point, don't they all start pulling on each other? I don't know. I'm a little confused by this whole setup here.
So I always thought they could be magnetic monopoles that would help explain everything.
Which no one has observed, and we're not sure if they exist in the universe. But go on.
Yeah, it's semantics. Okay, I think the real problem with every time I've seen a magnetic minefield in space is that it's three-dimensional space, and they're putting like a two-dimensional minefield, like essentially in front of you, so you just fly around it, and it's like it's not really any farther. So I understand at the end that was a different thing, but the first time they encounter the minefield, they could have just taken like a little right-hand turn and it would have been fine.
Yeah, gotta think three-dimensionally, as they say.
What about the idea of the ship being magnetic?
Yeah, I mean, presumably this is a magnetic minefield. We think that's why they're being pulled to the protector. So I guess it's magnetic. Maybe that makes some sense. There's some throwaway lines about plasma armor. Maybe that makes it no longer magnetic. I don't know. There's some technobabble
historically do not have magnetic attraction into them when they get to that state of matter. Typically, like there are some really weird plasmas out there that could have magnetic behavior, but they're pretty strange, and they typically are not armors of ships. Just typically. I'm just gonna go out there.
Yeah.
Okay. All right. How about this scene where they're fighting the dogfight in space?
Right. So this is something that pretty much every sci-fi movie, show, etc. gets wrong. Even my favorite, The Expanse, sometimes will get this kind of goofy. The ships seem to be aligned the same way. Always, the ships are always pointing at each other. Everybody, friends, enemies, Federation or not, have agreed on what up is. And so, suddenly they're all the same. But really, there's no up or down in space. You could be at any kind of different orientation. It really just does not matter. Nobody would notice. And so that's just bizarre. That bothers me. But, it's a quibble I'll bring up in lots of sci-fi movies.
Okay, fair enough. But I do think that we could see that in a sci-fi show. Just ships fighting kind of like upside down from each other. And that would be pretty cool and kind of accurate. And pretty much how I play most video games.
Right. But the fact that whenever there's like the good guys talking to the bad guys on screen, the ships are always pointing nose to nose, perfectly aligned. And that's just ridiculous. There's no reason. Like they should just be at all goofy angles as long as they're sort of in the area. Whatever.
Westeros gets it right though. There's galactic up. Just like we have magnetic north, there's galactic up. So I think that actually explains away everything.
There is a galactic North Pole. Most galaxies, certainly spiral galaxies like the Milky Way, are rotating. They're rotating around an axis, and so you can define using the right-hand rule which way is up in a galaxy if you really want to. So There is a galactic up.
Can't believe you agreed to that. All right, we're going to talk about technical. We're going to talk about the non-humanoid aliens, but first, I actually want to let's talk about the Stan Winston thing. So let me bring that up real quick. This is from the blog of Stan Winston, and I had this up somewhere. Let's see, is that showing on the screen? I believe it is.
Like it.
Okay, so this is a blog post on the Stan Winston School site talking about the design of some of the different creatures. And you can see the concept art for the cephalopod type Thermian design. I love how detailed this design is, and you can see them painting like the small scale model, then actually building it up, the mold that will eventually turn into the film, and you can see some of the armature that's actually inside of the puppet here, which I think is beautiful. But really, this is what takes home everything, is this paint job. Just look at like kind of the feather detail, the spotting that happens, which is so consistent with what we see in so many different cephalopods species. Like we see this oftentimes in squid, and I could talk forever about the ability of squid to change colors. But look at this large scale puppet. This is a masterpiece, right? And this is how long they're in the movie, in like real time. That's it.
Yeah.
That's all we got from them. And like we got like another like scene and a half of them in this puppet. So I love the detail. They also go into the Saurus, but I'm going to scroll down because we talked about it and talk about the pig lizard. So this is the initial sketch of the pig lizard, and this is the favorite thing that we should talk about. Like, this is what the mock-up of what a human inside the pig lizard was going to look like. And that, folks, is why Andy Serkis keeps getting work in Hollywood, is this level of commitment that it takes for this type of creature. But I love looking at like the detailing. Look at how much texture they get with this sculpt on the foam here. And let's just actually watch this short video of the pig lizard movement test. Hopefully it's not too loud. Look at that. Like, I mean, obviously there's somebody in that, inside of a white suit, moving around. That looks so uncomfortable.
Yeah, Shane, try walking forward like with a lot of bounce.
I like that they drew that, they made that sketch of the person like squatting hunched over in that suit. And some intern was like, oh crap, I'm going to have to do that. I know it.
I love these like dangly parts coming off the bottom of the suit too. And when you look at it from behind, it is, I mean, this hurts my back just looking at it, but this is adorable. This is
It's pretty
awesome.
hilarious.
Turn around.
It's an awesome piece. He almost ran into something there.
And for
now
what,
he's squatting and taking a poop.
Yep. One scene and, less than 3 minutes of screen time or something probably?
Again, basically no screen time. And then the classic Alan Rickman head sculpt here. And you can see they did a life mold cast of his head in order for this to be actually shaped around it, because that's Alan Rickman's head there, and you can see the cast that they did there. Just incredible overall work. There's a ton more on Stan Winston's YouTube channel where you can watch more behind the scenes footage. So I just want to say, like, I highly recommend that that series that Stan Winston did. Okay, let's see if PowerPoint actually starts up again. Nope, PowerPoint's gonna crash. Ah ha ha! It came back. Maybe.
There we go.
A little bit. It's slow. It doesn't want to come back, but it'll get there eventually. So we're gonna wait here and wait for PowerPoint to load. The best part of any presentation. All right.
Well,
so
we can start talking about non-humanoid aliens. So the creature making was impressive, but the science is pretty impressive behind these things too.
yeah, and I said this during the movie, but one of the more impressive parts is that they took a non-humanoid and especially cephalopod representation as a dominant species, because for millions of years on this planet, cephalopods were the dominant species. And so this isn't like an unusual thing to do. They're widely regarded as the most intelligent vertebrate. There's about 800 species of cephalopods right now. But back when they were the dominant species a few 100 million years ago, there's about 11,000 different species of cephalopods on the planet. And they dominated the greatest area on the planet, from the depths of the ocean all the way close to the surface of the ocean. Why are cephalopods considered so intelligent? Like, here is an image of an octopus actually twisting its way out of a jar and solving this puzzle. Intelligence is like this incredibly difficult thing to measure, especially in different animal species, because we don't just look at their total like number of neurons and do it, but we think of octopuses, and I will remind you that it's octopuses is the plural, not octopi, partially because they have intelligent characteristics like a sense of play, and they have personality, and they have the ability to take information in order to solve problems and adapt their behavior to solve those problems. And that's why we see octopuses oftentimes being challenged in museums by creating where people create puzzles for them. And speaking of puzzles, we actually did this. So as part of a series I shot on Tested called Science in Progress, Adam built a puzzle for an octopus at the California Academy of Sciences. And then I spent time there filming with the cephalopod staff and trainers, where we would give the octopus this puzzle every day in order to train on it. And there would be like salmon placed inside. So it had encouragement to do it. And pretty quickly, so the first iteration of this puzzle, it tore apart. It just broke the puzzle that Adam designed. And then he had to redesign it. And sadly, like, this process ended up taking like a couple of years because the octopus they had actually died. Octopuses only live a few years. They grow massively quick, but they don't have a long lifespan, typically on the order of like 5 to 7 years. So that one died. So we had to wait some time before they had a new octopus in. And so he rebuilt this thing just sort of at a clear kind of like plexi that the octopus had to spin the top of in order to get into this this area inside to get at the salmon. It was pretty incredible. So octopuses, why their neuronal structure is very different from other vertebrates. They have about 500 million neurons, but those neurons aren't centered in a brain or a central nervous system like we think about it with vertebrates. They're actually spread throughout their tentacles and throughout two areas that are typically called ganglia that control their optical system. And these ganglia also control their sort of sense of learning. The central system controls their kind of motor control, propulsion, and other kind of behavior. Like they actually have a beak that they actually the central nervous system controls that chews some of their food. But there's this whole peripheral nervous system in their arms that isn't just about propulsion. It has more functions of that. And so it's just absolutely fascinating to see a distributed neuronal system like this in octopus. And it's one of the reasons they're so intelligent. And within that, this is what's called a statocyst. A lot of cephalopods have this. So what happens is there are all these like really sensitive components in around this sort of what looks like a hollow area, and this cyst right here is very sensitive to acceleration. So it can feel minute changes in acceleration, and when it does, it creates a pressure force along these walls, and these walls carry a ton of neurons, and they sense that change in pressure and communicate it up to other areas for action. So octopuses and other cephalopods actually have the ability to detect small changes in gravity underwater and are able to sort of change their behavior based on it. We don't have a good sense of like how sensitive are they, but we know some squids actually have adapted their statocyst structure to quote unquote hear. They actually detect changes in sound waves below the ocean surface at somewhere between 30 and 500 hertz, which we would associate to audible range for humans. And if I haven't convinced you yet that cephalopods are really intelligent, some cephalopods can fly. That's right. This is a picture of cephalopods. I know it's a weird angle, but this is an image outside of Japan because it's always off the coast of Japan. I don't know why. It's all the weird stuff with animals happens off the coast of Japan. But this is an actual picture from 2011. These are flying squid. What they've done is they've ejected a piece of a jet of water from the bottom and ejects them above the surface of the ocean, and then they use their kind of appendages to glide, and they do this to actually hunt certain fish and other creatures towards the surface of the water. So here's a pack of squid gliding over the water if you want terrifying things to dream about tonight. But it just proves, once again, cephalopods are amazing creatures. And I have a book recommendation. Hang on one second. My friend Dana Staff, who used to do research at Stanford, I don't know if you can see the book, wrote a book called Squid Empire, which is about the history of cephalopod evolution on this planet, and really looked at the time that squid were the dominant species on Earth, and tells their kind of historical tale. It's an awesome read if you're really into cephalopods like me. Wow, I'm sure no one's watching this channel anymore after that rant on cephalopods. But we'll keep going.
I mean, yeah, we're just every week we're gonna do something else that gives us nightmares. This week it's flying squid coming out of the water.
Yeah, furious. I could talk about the chromatophores a lot, but it's time to talk beryllium. And so beryllium, real element, though it's relatively rare here on Earth. There's 0.1 parts per billion in the sun and about 2 to 6 parts per million in the Earth's crust and soil. It's metallic, and it forms in crystals, not spheres, but that's fine. You can carve it into spheres. But it certainly doesn't form in big spheres like we see in the movie, or smaller baseball-sized spheres as they rolled around. But the question is, how easy would it be to actually roll a big old beryllium sphere? Well, it's time for us to do the math. Okay, so for a metal, it's a fairly low density, but it still almost has twice the density of water, about 1.85 grams per cubic centimeter. The sphere looks to be about 1 meter or 1 yard in diameter, which means it has a radius of about half a meter or 50 centimeters. Density is mass divided by volume, which for a sphere is 4/3 pi r cubed. We can rearrange this to solve for mass and plug in our numbers to get that the beryllium sphere would weigh about 970 kilograms, or about 2,000 pounds, just a bit more than a ton, or slightly larger than a 2014 Nissan Versa, which weighs in at about 2,300 pounds. So, could they have rolled a beryllium sphere? Think about it this way. Could you roll a Nissan Versa down the street? And I think the answer is actually quite a hearty yes. It just would have become problematic when they rolled it on the ship.
Right, yeah. I think the issue is stopping it once it got rolling down the hill. But
yeah, potato. By Grapthar's hammer, channel the spirit, and you'd have the strength to handle it. No problem.
That seems reasonable enough. All right, let's move on to a bit towards the end of the movie that I really like. This is another one that, they got right, and, something that comes up in sci-fi movies, but they totally got it right. So they talk about how the main ship is too big to enter Earth's atmosphere. That's reasonable for a large starship. It's something that Star Trek, especially the reboots, mess up. You'll see the Enterprise jumping into atmospheres, into the ocean, all kinds of crazy stuff. That seems unlikely. But anyway, the Protector. So they say the command deck ship is much smaller and it can enter the atmosphere. It enters the atmosphere nose first, which is not great. You really want to dissipate the heat of friction as you're hitting the atmosphere. All those atmospheric gas particles hitting the bottom of your ship, that'll start heating up. And so you want to dissipate that. And so to do that, you want to maximize the surface area. So you really actually want to come in belly first. And that's what the space shuttle did. And you can see in this little picture, the inset here, that's a model of the space shuttle as it comes back into the atmosphere. With a color coding of the heat on the shuttle. And you can see the underside of the shuttle is where all those tiles were that can absorb a lot of heat, dissipate the heat, and you want to spread that over as much of the surface area as you could. So coming in belly first is a good idea, but coming in nose first, not a great idea, but at least we get some of this kind of waviness on the ship as it comes in from the friction and the heat from the atmosphere. So that's pretty cool. When the shuttle came back in the atmosphere, the bottom side would get up to almost 3,000 degrees Fahrenheit. So the front of the little top of the Protector is going to get pretty warm.
I did a rewatch of Apollo 13 a few weeks ago for the 50th anniversary. And this is a main point that happens on that mission is they get really worried that the angle that the ship is coming back in on is too shallow. And that they're going to encounter this exact problem when they re-enter the atmosphere and sort of break up. But they, spoiler, they get back to Earth safely. Okay, we have to talk about our favorite moment and probably the most important and the most accurate moment of science in the film.
Hey,
Don't open that! It's an alien planet! Is there air? You don't know!
Seems okay.
This is the definition of the scientific method in action. We don't see a better demonstration in all of film. I challenge you, chat, to show me a better film that demonstrates a scientific method in action. Marie Curie lived her life this way and died too. But there's been so many famous scientists who have experimented on themselves and put themselves in harm's way for their work. And so while in quarantine during the Great Plague of London in 1665, Isaac Newton poked needles between his eyelid and eye. Those are words I just said. To fiddle around with his optic nerves. Marie and Pierre Curie handled radioactive material with their bare hands. Won a Nobel Prize for it. Also died of radiation poisoning. Wilhelm Röntgen discovered X-rays, and his first X-ray images were of what? His wife's hand. I'm telling you, this is scientific history demonstrated. This is the most accurate thing you're going to see in all of the films.
I like Rankin was like, I've discovered X-rays. They might be dangerous. Hey, wife, come over here. Give me your hand. At least Pierre and Mary Curie were both doing the science and putting themselves in harm's way. Rankin's wife was just a bystander.
I also love how I had forgotten about how we included in this whole thing that Isaac Newton made this discovery during a quarantine of a pandemic. So all of you that are just sitting around watching two goofballs talk about a movie from 1999, what are you doing to experiment on yourselves? Yeah, that's what I'm saying.
Just jab pins in your eyeball, obviously. Duh. Okay, so taking this slightly more seriously, aside from the actual, this is the scientific method at work, we can actually do this with telescopes now. We can detect atmospheres around planets, around other stars, without having to send Tony Shalhoub and Sam Rockwell to go breathe the atmosphere and tell us what's going on. So telescopes like the Keck Observatory on Mauna Kea on the Big Island in the top left, the bottom left, the NASA Infrared Telescope on the same mountain, and the Hubble Space Telescope on the right there have all done these kinds of observations of planets around other stars and actually detecting atmospheres of those planets and what chemicals are in those atmospheres. Is there signs of life? Could they be habitable, breathable, etc.? And so here's one of the best observations that we have of this. An astronomer from JPL named Mark Swain and his collaborators observed a hot Jupiter-sized planet around this star, HD 189733. Again, a very exciting name. Good job, astronomers.
Better than White Hole. Still better than White Hole.
That's fine. People, you have your opinions. That's fine. But this boringly named star has a planet around it, a big hot Jupiter. And so back in 2007, they observed the actual planet itself, and they could actually get what's known as a spectrum, sort of a fingerprint of the elements and the molecules that are part of that planet. And they detected what appears to be an atmosphere with carbon dioxide and water and methane. And so this has only been done for a handful of planets. It's very difficult observation. The planet's much, much fainter than the star. The atmosphere is even tougher to detect. But we're starting to see, the ability to do this in the past 10 to 15 years on more and more planets. And so actually being able to detect the spectrum from afar with space telescopes and ground-based telescopes, as opposed to sending our heroes to the planet itself. And so in the future, we'll be able to do this even better with the James Webb Space Telescope. Here's a full-size model of it at South by Southwest a few years ago in Austin. And so this thing is supposed to be launched next March. We'll see if that slips. Unfortunately, I think it will probably slip into the future with all the stuff going on these days. But hopefully it'll get up there into space. It'll be more powerful than Hubble and be able to detect. One of its main missions is to look at exoplanets and look at their atmospheres. So we'll be able to get lots of observations of planets around other stars and what their atmosphere looks like.
All this just reminds me of one of I think the more important telescopes that we haven't discussed yet, which is the Smelloscope from Futurama, which, by the way, I know I'm making fun, has a real analog. This is the Nasal Ranger, which is deployed in Denver after marijuana legalization in 2013 to quantify the quote-unquote stink pollution that came from exuberant smokers. Does it work? I don't know if I actually really want to know if it works or not. I just like the fact that this is an image for the nasal ranger. And I have to give props to whichever company came up to this, because that is a really good name for whatever this device is.
I like the phrase exuberant smokers.
Yeah, we call them different names where I live. Like just people on the street. I don't know. Just
Yeah,
people.
right, sure.
No problem. All right. So
Okay,
we've talked
so-
a lot about the science. We have to see, what did we learn?
What have we learned? What have we learned from this film?
I think we learned that number one, most Star Trek movies stink,
Sure.
and that Galaxy Quest is not one of them.
That's right. I think we learned that we need more black hole transport and less magnets, or fewer magnets in space. Definitely.
And slightly better names for what comes out the other side of a black hole.
Okay.
I think if for those that are starved for sports right now, Beryllium bowling could be a sport that I would tune into right now, given that we probably aren't going to see sports for a little while longer.
All right. We really like this movie. We usually give our movies ratings. This is kind of a special rating because we love it so much. I think we just agree with the Thermians in general here about how much we love Galaxy Quest.
Love this movie. I think this is the highest rating we can give a movie. Is Thermians
sure.
clapping for anything. Thanks for sticking around and putting up with us chatting about the science and all sorts of